All right, welcome back to the 22nd episode of uh, Swish writing a closure with Claude for Swift. Um, so a lot of more progress made this week. We implemented a bunch of sequence utils and other functions that were required by them. Before I go any further, I want to just um, please like and subscribe this video, and if you please comment below if you want me to do something different. You want more information, you want more in depth, you want more demos, whatever you want, let me know below. And if you want to support my work, which I would really appreciate, you can buy me a coffee, links below. And a reminder, in the show notes below is also a link to the repo where you can try everything out yourself. So last week what we did is we implemented the sequence utils, as I said before. So here they are. We got drop while working, last, but last, reverse, flatten, partition, partition all, group by, frequencies, sort by, distinct, interleave, interpose, zip map, keep indexed, map indexed, do all, do seek, and for. And to support those, we added the max and min functions, a let fn macro with the peek and pop, and also win first, and the reader shortcuts for anonymous functions. And next up, we'll be implementing lazy sequences. And if we look at our roadmap again, we are basically done with tier 1. We're in tier 2. Next up is going to be lazy sequences. So that's pretty much it, what I got accomplished. I wanted to show off some of these functions. We'll demo some of them. So let's just we got drop while. So drop while even, it'll just give us, while the even numbers are even, it'll drop them. We ended up with 9 and 10. Last will return the last item in the list or the vector. That'll give us just 3. We've got but last, which will give us everything but the last element, which is just 1 and 2. We've got this little bit of code that will reverse the string and give us a new string. We've got flatten, which will flatten the vector. We've got partition, and we're going to partition this vector into 2 elements each. So we get 1 and 2, 3 and 4, 4 and 5 and 6. And you notice they're all returning sequences, just like closure does. Partition all will do the same thing, but it will do all of the elements, even if they're not an even number in this case. So 7 ends up in its own partition. Now we got group by. We're going to group all these elements by whether they're even or not. So by the false, the other, or the odd numbers 1, 3, 5, and the even numbers 2, 4, 6. Here's frequencies, which is going to return a map of how many times each letter occurs, keyed by that letter. Here's sort, which is going to sort the elements. So we get 1, 2, 3, 4, 5, 5, 5. Here's sort by, and we're going to tell it sort by the name, these maps by name, an array of maps. And we get Charlie and Rod. Distinct, it's going to give all the distinct elements in the vector. I'm going to clear this and move this up here. So we just get 1, 2, 3, 4. Interleave is going to interleave these two vectors together. So we'll get 1, 2, 3, 4, 5, 6. Here's another interpose, which is going to put a dash between each character, and then we return it back to a string, so we get hello with dashes in between each letter. Zip map is going to zip these two together and create a maps with, so the first vector is the keys, the second vector is the values, so we'll get a map with those keys and values. Keep, that is going to return, basically we're going to keep all the even numbers in the collection. The function you pass to it has to return. Keep returns all the non-nil values, so here we're going to just return all the even numbers to 2, 4, 6. Keep indexed. It's very similar, but you also get past the index to your function. So here we're saying if the number is even, return the index. So we're going to get all the indexes of the even numbers. So 0, 1, 3, and 5 are even numbers. Map indexed also creates a you give it a function that gets an index and an item, and you can map over those things. So in this case, we're going to return a new sequence with the index of each of these incremented. So instead of 0 through 5, we get 1 through 6. Do sequence. This is just going to go through the sequence and assign for each iteration through the sequence. X gets one of these elements of the sequence, and we're printing X. And 4, we got 4 comprehensions. X is 1, 2, 3. Y is 2, 4, 5. For every combination of those, we're just going to multiply them together, and we get all these results. 1 times 2, 1 times 4, 1 times 5, 2 times 2, 2 times 4, etc. All right, so there you can see that all our sequence utilities are working. Let's see. We can look at Clojure Core. It continues to grow. It's getting pretty big. And these are mostly copied right from Clojure Core. There's a few adjustments that had to be made, mostly because we do not have lazy sequences yet. So that is next on our to-do list. We're going to get lazy sequencing working properly, and then transducers. So we'll see. Then we can move on to strings and set and whatnot. So that's my latest progress. I hope you like it. I hope you're actually downloading it and looking at it. I hope you find it useful. Embed it in your Swift app. At some point I'll do an embedding example. And again, please like and subscribe. Buy me a coffee. And if you need some help with Swift development, I'm available. I'm also would be interested in doing some Clojure work, so please get in contact with me. Until next time, thanks.